In this video, we're going to talk about power. We're going to go back to our example of an admissions officer. In a previous video, we did this. Our null hypothesis was the mean income and GPA was less than or equal to 3.5. The alternative was that it was greater than 3.5. We used an alpha of 0.05. We found our rejection criteria based on that alpha, and that rejection criteria was the 3.6 value. Our sample mean was 3.5, so we failed to reject. In this case, we would be interested in what's the power of this test. Let's draw a picture to show what this looks like. So again, here we're looking at the distribution of y bar. That's our point estimate. Under the null, we're centered at 3.5. It's normal by the central limit theorem. Our alternative was greater. Our decision criteria was a 3.6. That's so that this area would be 5%. As we were to the left of that, we failed to reject. What would be nice to know is this area here, which is beta. Probably a type 2 error. We want to calculate beta. Beta is the probability that we fail to reject given that the alternative is true. What makes this calculation difficult is what is that value for the alternative? Oftentimes it has to come from a subject matter expert. Suppose our subject matter expert told us the difference that meant something as an admissions officer was 0.1. In other words, they're looking for a difference in average GPA of 0.1. In that case, the alternative would be 3.6. Again, this came from a subject matter expert. In terms of what they think is a relevant, important difference. Alright, we need to do that calculation. So this is a probability calculation. Again, it's the probability of y bar less than or equal to 3.6, given that mu equals 3.6. I'm going to do this in R. It's the p norm command. We want to be less than 3%, given the mean is 3.6, and our standard dev is 0.23 over 64. I actually don't really need R because I'm looking for a probability less than the mean. That's equal to 50%. Beta is 50%. Our probability of a type 1 error is 50%, which is fairly large. At this point, you're wondering, well, what can we do about that? If we take a look at our drawing again, the only thing that we could change in here is if we, let's change to red, if we increased our sample size. What would happen if we increased our sample size? The distribution of the mean would be narrower. With the same alpha, the decision criteria would move to the left, and we were more likely to be able to detect that difference of 3.6. So then the question becomes, what value do we need? In the follow-up video, we'll talk about the sample size calculation.